Analysis of forces in SHM. Give heading. Analysis of forces. Analysis of forces in SHM. Okay. We'll see how the forces are acting in SHM. Friends, there are few things that should be that must be carefully followed while analyzing SHM of a particle. So, like that, there are so many things we have already discussed in the early classes, like displace the particle from the mean position. Yes or no? You take the case of a simple pendulum. What happens? This is the mean position. Yes or no? This is the positive extreme position, and we have already taken this point is the negative extreme position. Yes or no? It goes like that. Again, it comes back. Again, it comes. This is one cycle. Already we have discussed these things. Yes, so actually, students, the point that should be taken care is displace the particle from the mean position. Mean position means what? Equilibrium position by a distance x along the line of SHM. That means we should force is proportional to displacement. And student, हमेशा हमें क्या करना होगा? We have to analyze the force on the particle and try to show that the magnitude of the net force is always proportional to the displacement. Yes or no? If I'll give you more force, then the displacement will be more. If I'll give less force, then the displacement will be less. So how much will be the displacement? That depends on the applied force. Yes or no? So that means one point is very important. The magnitude of the net force should be proportional to the displacement x. Yes or no? And another one thing, student, we have given the force in this direction and it has got displaced to this position, but it wants to come back to which position always? Towards the equilibrium position or toward the mean position? Yes or no? And student,
Yes, sir.
second point is that the force is always directed. That force is known as restoring. The force is always directed, right? The force is directed towards mean position. ये भी एक जरूरी point है. Towards mean position is always directed towards mean position. That means it has a restoring nature. That means it has a restoring nature. It has a restoring nature. Okay. And the proportionality constant, we always find the proportionality constant. F proportional to x means f is equal to minus kx. You know that. And we have to find the value of proportionality constant k from the expression from the magnitude of force. Always this is important and this varies from cases to cases. Time period. Time period is what? 2 pi by omega. Na? And omega we have already derived. Omega is equal to how much? K by m. Na? Yes or no? So time period we can write always 2 pi root over m by k. And for different cases, we'll see how this proportionality constant k is varying. Yes or no? So now we'll see various examples of SHM, like simple pendulum, like liquid oscillating in a U tube. Yes or no? Oscillation of a cylinder floating in a liquid. There are a few other cases, but we'll see these cases today. How the SHM is happening, yes or no, and how to find the frequency, time period, and the proportionality constant value. How to find those things, yes or no. So let's give heading simple pendulum. Next, write simple pendulum. We'll see the various parameters. Simple pendulum. Listen. Let's take the example, student. Let's see here. This is the simple pendulum case, okay? And already in your work per energy, and you have learned the mechanics about that. That means how the everything varies. Let it has displaced angle theta with the application of force. And this is the tension force T, yes or no? And always weight acts vertically downward. This one also if this angle is theta, then this angle is going to be theta, correct? And the component is going to be mg cos theta. And the restoring force that brings back to the mean position, that is how much? Another component of mg is mg sin theta. Is that clear? So friends, simple pendulum is an idealized body. Simple pendulum ke bare mein when it comes to mind, so it's a body consisting of a point mass. That means the pendulum is having a point mass suspended by a light inextensible string. Means that is it's not elastic one, it's a rigid one. And when pulled to one side from the equilibrium position, जब हम इस simple pendulum को equilibrium position से एक point की तरफ pull करते हैं, yes or no, and release करते हैं, then क्या होता है? The pendulum oscillates. The pendulum oscillates, yes or no? Let this length of the string that is connected to the bob is L, okay? And mass of the simple pendulum M we have already taken, yes or no? And let it is making an angle theta, correct, with the vertical. Then the force acting, that is mg or weight. So this is gravitational pull of earth, and there is a tension. Okay, students, the axis along the tangent means let this is a circular path, and this is the path of path. This is like a arc, na? We can compare this one like a arc or not. This is like a arc path, where length is the radius, and this is the theta, and this is the path length, arc path. Yes or no? So it's the radial component of the magnitude is how much? Mg cos theta. Yes or no? Which is going to balance the tension. Yes or no? The tension is going to be balanced by the mg cos theta is going to balance the tension. Yes or no? And the tangential component is mg sin theta. Yes or no? That is the restoring force acting on the mass m, which let's takes the body to the equilibrium state. Yes or no? So the magnitude of the restoring force is which force is trying to bring it to the mean position? Mg sin theta. So we can write the magnitude of restoring force. The magnitude of restoring force F is equal to how much? Mg sin theta. ये कौन सी डायरेक्शन पे एक्ट कर रहा है? It is acting towards the mean position. It is acting towards mean position. It's acting towards mean position. Okay. And so if the angle is very small, then you know sin theta can be written as theta. Sin theta can be written as theta. So we can write F is equal to how much? Mg theta. And theta is what? Angular displacement. For very small angle, we can write sin theta equivalent to theta. And that is mg theta. Theta is here angular displacement. This theta is what? Theta is angular displacement. Okay. Let the magnitude of the displacement is along the arc is x. Yes or no? Let the magnitude of is x. Let this is the magnitude of displacement. Yes or no? And you know, for very small, this arc looks like a the arc looks like a angle theta. Yes or no? The arc looks like angle theta. Correct. So if f is equal to mg theta, yes or no? So we can write f is approximately equal to m theta. And you know, in case of arc, theta is equal to L by R. Theta is equal to L by R, you know. But here, what is in place of radius? L. What is in place of L? X. Na? So we can write in here, theta is equal to x by L. We can write or not? We can write theta is equal to x by L. X is the arc path, arc length, and L is the radius. Theta is equal to L by R. And in place of arc length, we wrote x. And in place of radius, we wrote L. So here we can, in place of mg theta, we can also write mg x by L. Understood? And student, it is SHM. We have already learned in the previous class. F is proportional to x, and F is equal to kx. Correct? And just now we got F is equal to how much? Mg x by L. Both are same, na? So by comparing these things, we can write kx is equal to how much? Mg x by L. Correct? By cancelling x, what you will get? The constant value is going to be how much? Mg by L. Okay, we got the value of k. And simple pendulum time period, SHM का time period क्या था formula? 2 pi root under m by k. Just before slide we highlight, you know, you just knew t is equal to 2 pi m by k. If t is equal to 2 pi m by k, then we can write 2 pi into, in place of m you put in place of k, what I can write? Mg by L. Okay, this mm will be cancelled. Then we can write time period is equal to how much? 2 pi root under L by g. Now you will be clear why we usually take time period of simple pendulum is t is equal to 2 pi root under L by g. If it is and if it is asking about frequency, then frequency is equal to how much? 1 by 2 pi root over k by m. Or you reciprocate directly. That is frequency is going to be how much? 1 by 2 pi root under L by g. Correct? That is going to be the frequency. So this is the expression for time period of a simple pendulum. And after learning SHM, you got to know how this formula came into being. Okay. Students, next we'll see about liquid oscillating in a U-tube. That is also another case of SHM. Yes or no? You could visualize the thing. Liquid oscillating in a U-tube. liquid oscillating in a U-tube. Correct. That means at equilibrium, the liquid level is at this place in a U-tube. If some force will be given, then what will happen? The liquid level will to and from motion होगा. तो अगर ये x नीचे की तरफ आ जाता है लिक्विड, तो ये लिक्विड इस लेवल से x ऊपर की तरफ चला जाएगा. अगर इस पोजीशन पे देखूं तो दिस टोटल लेंथ इज x and consider the liquid column of total length 2L, right? Liquid column, consider liquid column of total length of total length 2L inside a U-tube. Inside a U-tube. Okay. Inside a U-tube. Okay, understood this one? We'll go to find what is the time period is going to be in this case, yes or no? See very carefully, the derivation is very easy, yes or no? And directly you can also know. Students, from the equilibrium, here you see from the equilibrium, let the liquid is displaced from the state of equilibrium by a distance x. This distance we have taken as x, correct? And it is clear from the diagram that the total difference in the liquid level becomes 2x. Yes or no? The lower level and higher level के बीच में gap कितना हो गया? 2x. Logically, you can see this one. Friends, consider a cross section A, B, C, D. Yes or no? Uniform. The area is uniform throughout. So the restoring force acting on the liquid is what? Excess pressure due to the column ABCD. Yes or no? Students, here the restoring force, right? The restoring force. Pressure is equal to force by area, na? Yes or no? So force means pressure into area. So the restoring force acting on the liquid, right? Restoring force acting on the liquid. Restoring force acting on the liquid is the thrust. Is the thrust of excess pressure. Is the thrust of excess pressure due to the column ABCD. Due to the column ABCD. Understood? Here you see the column ABCD. यहाँ पर pressure difference क्या है? यहाँ पर pressure difference क्या है? अगर pressure के साथ area को multiply कर देंगे तो क्या मिलेगा? हमें force मिल जाएगा. So we can find. So let's find the magnitude of the restoring force. That is force. The force is going to be F is equal to how much, students? Pressure into area. Force is going to be how much? Pressure into area. Yes sir. And pressure, you know, rho gh. Already you have learned in fluid. Force is equal to pressure into area. Yes sir. Pressure is equal to how much, student? Rho gh. What will take the h? What will take the h? 2x, na? The height is how much? From this level to this level. What is the height? 2x, na? So rho g into height is 2x into a. That is going to be the force. And so here also x is there. Here also for a particular liquid, rho is constant, g is constant, area is constant, 2 is constant. So x depends. ये कितना force दिए हुए हैं. So that's why we got A proportional to x. That means this is also the case of SHM. If F is proportional to x, then the liquid executes SHM. Definitely we can say. It means the liquid executes SHM. Okay. So if I'll compare this one, if I'll compare F is equal to Kx, and here we got F is equal to rho G 2A into X. See this XX. Then in place of K, what we can write? What is in place of K? See this one. In place of K, so the constant is equal to how much? 2A rho G, correct? We got the constant value. Once you got the constant value K, then you can put in the time period, 2 pi root under M by K. Let's put it. So that is T is equal to 2 pi root under A. In place of M, you put M. In place of K, you put 2A rho G. Correct? 2A rho G. Yes or no? So let's see here. Mass is equal to what, student? Density into volume. Na? Normally, mass is equal to density into volume. Yes or no? Density, in place of density, you write density. But in place of volume, what you will write? Area of the pipe is A. And what is the length of the liquid column total? 2L. Na? I told you. So in place of volume, you can write area into total length. Total length is 2L. We have taken liquid column of total length, how much? 2L. So what is the volume of the liquid column is going to be? Total area A into 2L. So in place of A, I can put that one. So let's replace it. 2 pi root over. Here in place of M, you put A into 2L into rho, yes or no, divided by 2L rho G. Yes or no? LL is G here. What is going to be? See here. 2 नीचे कितना था 2a rho G था 2a rho G. Yes or no? A cancel, 2 cancel, rho cancel. Yes or no? So final students, you see we got T is equal to T pi root over L by G. Here also, if the length of the tube is given L, I have taken here 2L. So that's why it is L by G. If the length of the liquid column given 50 meter or 20 meter, 30 meter, then the half you have to take always here. This is the generalized formula for time period of a liquid oscillating in a U-tube. Only confusion is that students see the U-tube length is given, but you have to take the half here. I have taken 2L, that's why it came into L. अगर हम यहाँ पर L लेते तो यहाँ पर कितना आता? L by 2 आता. So this is the expression for the time period of a liquid oscillating in a U-tube. I think it's that clear. Students, consider a cylinder of mass M. Let's say this cylinder is having mass M and density is D of this cylinder that is floating in a liquid. Density of the liquid, let rho, okay, and total length of the cylinder is capital L. You can see here. And the length that is immersed in the liquid at equilibrium, that means weight is equal to of thrust. अगर balance करेंगे तो let this is the L at equilibrium, and let A is the area of cross section. We apply law of flotation on the cylinder. अगर हम law of cylinder इसके ऊपर apply करें, students यहाँ पर इक्विलिब्रियम पे है सिलेंडर, ठीक है, मतलब वेट इज इक्वल टू ऑफ थ्रस्ट. अगर सिलेंडर की बात करें तो सिलेंडर की तरफ क्या फोर्स लग रहा है? एक mg और एक बॉन्ड फोर्स बी एफ वी. यस सर. अगर स्टूडेंट सिलेंडर इज डिस्प्लेस डाउनवर्ड बाय x, अगर हमने सिलेंडर को नीचे की तरफ x डिस्प्लेस करवा दिए तो अभी पानी के अंदर कितना चला जाएगा? l प्लस x. यस सर. चलो देखते हैं इसका क्या होता है. फर्स्ट लेट्स सी वेदर इट इज एसएचएम और नॉट. फर्स्ट लेट्स सी. सो अगर हम यहाँ पर उसकी फोर्स के ऊपर देखेंगे तो एक है बॉन्ड फोर्स और एक है वेट. So we can write at equilibrium. Already law of flotation you have learned this one. At equilibrium, weight is equal to of thrust. Yes or no, students? Weight is equal to of thrust. Correct. Weight is equal to how much? Mg. Of thrust is equal to how much? Total volume of the solid inside into density of the solid liquid into G. Yes or no? That is the bond force. और ये V क्या है? V is the volume. V is the volume inside the liquid. Volume of body means cylinder. Volume of body inside liquid. Correct. So this volume can be how much, students? And here you see mg. In place of mg, what I can write? I can also write density into volume. Yes or no? You can also write density into volume. This is weight. Density of the body d. We have taken your d. So you can write density into volume. In place of volume, what can we write? A into L. A is area, na here. Here you see A is area, and this is the length L. So we can write A into L. Correct. Into dg. That is equal to A, volume is also A into L, small l. Why? Because small l is inside, na students, at equilibrium. Small l is inside. Na? So what is the volume of the inside part? It is A into L. A into L into rho था पहले into G. तो अगर कैंसिल कर देंगे G को और A को तो हमें क्या मिलेगा? L into density D is equal to L small l into rho. A मिलेगा ना हमें कंडीशन स्टूडेंट्स? Yes or no? L into D is equal to rho into L मिलेगा ना? Yes or no, students? So if the cylinder is displaced from the main position, ये equilibrium पे था, हमने उसको main position से displace कर दिया, main position से displace कर दिया नीचे की तरफ. Yes or no? So ये downward की तरफ plate x displace हुआ. अगर downward की तरफ ये x displace हो रहा है, then net force acting on this will be how much? F भी ऊपर की तरफ था, अभी मैंने नीचे की तरफ थोड़ा F force दे दिया, तो मतलब ये जो applied force क्या हो जाएगा? That will be equal to B minus mg. Yes or no? स्टूडेंट मैग्नीट्यूड ऑफ नेट फोर्स, अगर हमने एक फोर्स अप्लाई किए, सो मैग्नीट्यूड ऑफ नेट फोर्स, राइट, मैग्नीट्यूड ऑफ नेट फोर्स that is F is equal to B bond C minus mg. These bond force, yes or no? On bond force how much you got? That F is equal to bond force is how much now? L था, अभी x डिस्प्लेस हुआ है तो L plus x कर देंगे into total area A था into density of liquid rho into G minus mg के बदले में क्या लिखेंगे? लेंथ into total area A into D into G. ठीक है, अगर दोनों को ओपन करके सॉल्व कर देंगे तो क्या हो जाएगा, A rho G whole into X. Correct? That is what? That is the force. And you see area is constant, rho is constant, G is constant. So here also you are seeing now F proportional to X. So this is the case of SHM also. You can take this one as the case of SHM. So if I'll compare this one with F is equal to Kx, then forget about X in place of K. What we can write? So we got the constant K is equal to how much? A rho G. Understood? This is the case of constant K. And you know time period T is equal to how much? 2 pi root under always what we are doing M by K. So that is equal to 2 pi root under. This is M by K. In place of K, what I can write? A rho G. Correct? But the thing is not over here. We'll solve this one in the next slide. Okay. Let's see. 2 pi is equal to M by A rho G. Let's see how it is becoming. So in the previous slide, you got T is equal to 2 pi root under how much? M by A rho G. Yes or no? So that is, you know, student, mass is equal to how much? Area into length, total body ka, into D. And already we have got LD is equal to how much? Small l into rho. So in place of LD, you can write rho L. So you can again replace it. T is equal to 2 pi root over. In place of L and D, you can write L rho. So here we put A L D divided by how much? A rho G, correct? And that is equal to 2 pi root over, yes or no? A rho L we can write. And niche kya tha? A rho G tha. So this one cancel. So here also we got how much? T is equal to 2 pi root under L by G. Understood? What is L here? Small l. How much is inside? Yes or no? That depends कि ये कितने time तक oscillate करेगा. Length of the cylinder inside will decide for how much time it will oscillate. So T is equal to 2 pi root under L by G. Hence the time period depends only on the length of the immersed person. Yes or no? So I can write time period depends. Time period depends only on the length of the immersed person. Only on the length of the immersed person. Immersed person. Okay. This is the thing on which the time period depends only on the length of the immersed person. Okay. Understood, students?